Hello again. In the last video, we used trigonometric functions to find a trigonometric function given another trigonometric function. This time we're going to use identities for the same thing. So these examples that we see here can be done by the methods of the last video. But this time we're going to find a specific trigonometric function given another trigonometric function using identities. What are identities? Well, we have here an example of what we call reciprocal identities. So if you know 1 over cosecant, 1 over cosecant is going to be sine. Let's talk about why that is. From the last section, we learned the definition of the 6 trigonometric functions. So for instance, sine of theta we know is y over r, where if you had a right triangle, this is theta, y, x, and r in standard position. We know that the trig function for sine is the y, the opposite over the hypotenuse. And we know that cosecant, we saw in that section, is going to be r over y. So you can see that these are the flip of each other. That's why sine of theta is 1 over cosecant of theta. And you can see for the one below it that the same thing is true. Cosecant would be 1 over sine as well. So that really shows the first two. Let's do a different column. Let's look at this middle column. Cosine is 1 over secant, and secant is 1 over cosine. So looking at cosine, the definition of cosine in the last section, if you remember, is the x over the r. The definition of secant, we know, is the r over the x. So again, those are the flips of each other. When you flip cosine, 1 over secant, you're going to get cosine and vice versa. And finally, the last two, maybe in a different color, blue, we're going to see that this is the same thing because tangent of theta we know is y over x, and cotangent of theta is x over y. Which means, if we look at an example using the reciprocal identities, we do not need to draw a picture if you see cosine. You can use these identities. So if you want to know cosine, given that secant is 5 over 3, you can just flip it. We know that cosine of theta is 1 over secant of theta, which is 1 divided by 5/3. Which, by the way, 1 divided by 5/3, what is that? That's just the flip. That is going to be equal to 1 times 3 over 5, which is just 3/5. Let's just flip it. Let's look at part B. We have sine of theta, given that cosecant of theta is negative square root of 12 over 2. So again, sine of theta is equal to 1 over cosecant of theta from above. So that is a flip. So I'm going to make that, I'm just going to flip it this time. So negative 2 over square root of 12. Now, in my math lab, they're going to say simplify the radical. They're not going to want radicals in the denominator. There's two things you can do here. You can simplify radical 12 because radical 12 is 4 times radical 3. Or I should say radical 4 times 3. And square root of 4 we know is 2. So this would be a 2. Square root of 4 is 2 times radical 3, and the 2's cancel. That would be a simplified answer. If they don't want the radicals in the denominator, you can multiply, let me rewrite it here, both sides by radical 3 to get rid of the radical in the denominator. So this would be minus radical 3 over square root of 9, which is minus radical 3 over 3. So depending on what your answer is. this first answer is simplifying. The second answer is rationalizing denominator, depending on what they want, or both. Okay, so we could have done this. We didn't have to use identities to solve this. You could have done this the same as the last video. You could have drawn a picture. Let me go ahead and show that. You do not need to do it this way. You can choose your method using identities or using the definition and drawing a picture. So let's try that. What I'm going to do is call cosecant, we know, is r over y. And what I'm going to do is I'm going to go up here. I'm going to let r should never be negative, so it's going to be square root of 12, and y is going to be 2. Oh, I'm sorry, negative 2, to get that negative in there. I'm going to draw a little picture. This is going to be either in the fourth or the third quadrant. I'll just make it the fourth quadrant, but it could have been the third just as easy. And this would be, the y would be negative 2, and the r would be square root of 12. But we don't need it, because what is sine of theta? Sine of theta, we know, is the y over the r. So the y over the r, and the y is negative square root of 2, and the r is, the y is negative 2, and the r is the square root of 12, which, by the way, if you do this in pink, is exactly what we got right here. So you can then simplify it the same as you did before. There's two other type of identities, quotient identities and the Pythagorean theorem identities. So let's look at quotient first. So this is for all angles. This actually should say theta, for which the denominators are not 0. The following identities hold. You can see that this would work, because if I start with the right side, sine of theta over cosine of theta, and I do the definition of sine. What was that definition of sine? It was y over r, if you remember from up there, y over r, and cosine was x over r. If you divide these, y over r divided by x over r, you flip the second one, and you can see the r's cancel, and you get y over x, which is indeed tangent of theta. You can do the same thing for the next one, cosine of theta over sine of theta. Again, this is x over r. Obviously, it would be the flip of tangent, which is cotangent, but let's just try it again the same way, y over r. So again, that's x over r divided by y over r. Dividing fractions, you flip the second one, times r over y. The r's cancel, giving you x over y, which is indeed, if I go to the left a little, it's cotangent of theta by definition of cotangent. We also have Pythagorean identities. Again, this should be theta. The first one, if you start with x squared plus y squared equals r squared, and you divide everything by r squared, just divide everything by r squared, you would get x over r squared plus y over r squared equals 1. And by the way, this is cosine, that's the definition of cosine, plus sine. So we know, believe it or not, they have it as sine squared, but it's the same idea. Sine squared plus cosine squared equals 1. The second one, to get the second one, I'm going to take x squared plus y squared equals r squared again, and I'm going to divide everything by x squared. So this would be 1 plus y over x squared equals r over x squared. So we get 1 plus tangent squared, because y over x is tangent, equals secant squared. Interesting, isn't it? They have it as tangent squared plus 1 is equal to secant squared. That would be the second one. We have the first and the second. To get the third, I'm going to take my x squared plus y squared equals r squared again, and I'm going to divide this time everything by y squared. So what do we get? We get x over y squared plus 1 equals r over y squared. So this is cotangent squared plus 1 equals, that would be cosecant squared. Usually they put the squared in front of the trig, but this does mean cosecant quantity squared, or 1 plus cotangent squared equals cosecant squared. We get the last one. And again, that's supposed to be a theta. Oh, I did x's, but we can do those with thetas. Should have done those with thetas to be consistent. So finally, we can now use these two identities to look at example 6. So example 6, let's check that out. So we want to find sine of theta and tangent of theta given that cosine is equal to negative square root of 3 over 4. So I'm going to use the fact that sine squared theta plus, I'm going to use identities. Again, we can use the methods that we learned in the last video, but this video I'm going to show you using the identities, and I'm going to use the Pythagorean identity, sine squared plus cosine squared equals 1. I'm just going to plug in, so we know that sine squared of theta plus cosine. Cosine we know is negative square root of 3 over 4, because that's what they're giving you. And so if I plug this in, I get this is 3 over 16. I can subtract 3 over 16 from both sides. And I can get an LCD, 16 over 16. So that looks like it's 13 over 16. So therefore, let me go down just a little bit. Taking the square root of both sides, let me just rewrite this. Square root, sine of theta would equal to square root of 13 over 4, because square root of 16 over 4. I'm not going to use, it really is plus or minus, but they did tell us that sine of theta was positive, so we know that this should be a positive answer. And that's how you'd find sine. To get tangent, we can now say tangent of theta, use the quotient identity maybe, sine over cosine. So let's go over here. Tangent of theta was sine over cosine in the quotient identity, the left one here. So what do we have? We know that sine is square root of 13 over 4. We know that cosine is negative square root of 3 over 4. So what do we have? Square root of 13 over negative square root of 3. You cannot simplify that. And how did I get that? If you want to know, I crossed out the 4's, but if you don't see it, you can write it like this. Divided by or times the flip. So you can see that the 4's do cancel. And then I'm going to rationalize it. You cannot simplify either one of those radicals, but you could rationalize by multiplying top and bottom by radical 3. So we get this numerator is square root of 39. The denominator is 3. That would be the answer for tangent. So actually I'm going to rewrite it over here. Tangent of theta is equal to negative square root of 39 over 3. You can do this. I'll erase my circle there. You can do this by the other method, right? By drawing a picture, if you would rather. That always works as well. you can see the last video, the method for that. Hope that helps.